Hi, my name is Zishan Khan and I'm going to present my project for the course CSE 8803 Big Data for Healthcare. In this project, I have created a scalable architecture for an open source big data healthcare analytics tool called OHDSI. To get the most out of big data analytics, a scalable architecture is needed for analysis. However, most healthcare platforms uses traditional SQL-based analysis that is bound to fail considering the growth in digital data. Through this project, a scalable architecture is proposed for OHDSI using Apache Spark and Zipline. The Observational Health Data Sciences and Informatics program is an open source interdisciplinary collaborative that brings out the value of health care data through large-scale analytics. It has several tools for carrying out analytics, and one such tool is called OHDSI. This tool provides descriptive statistics about an observational health care database, essential to explore the data before building healthcare applications. This is the current dashboard that uses SQL and R to pre-compute vital statistics and then visualize it in an interactive web dashboard. Scalability is a major concern for really big data sets. Also, it has two separate components. One is an R package in backend to connect to database and produce JSON files, and the other is the front-end web data visualization. To create any data analytics tool, it is essential that the input data conforms to certain formats and models. OHDSI has created a common data model to simplify the task of running these analytics tools on datasets from different sources. For this project, datasets that is already in CDML form is used. To create a scalable version of OHDSI, Spark with Scala is used as backend. Spark allows us to perform in-memory distributed computing that scales very well for large datasets. Also, the front-end is improved by using Apache Zipline that creates a web-based dashboards. It allows us to write interactive data queries and data visualization on the same web interface. Using Spark and Zipline, we create a single seamless scalable framework better than what OHDSI provides. To run Apache Spark, to run Spark programs and measure the scalability of the new infrastructure, Amazon Web Services are used, mainly its EMR, S3 and EC2 instance services. Amazon EMR cluster with Spark was launched with 2 slave nodes and 1 master node. A separate EC2 instance was launched with Zipline running as an application of the cluster. The SynPof data in CDML format was uploaded on the public AWS S3 bucket. Statistics and queries are written in Scala in the web interface to get better visualization as provided by OHDSI. Spark programs were submitted to the EMR cluster directly from the Zipline instance through the web interface. This block diagram shows the architecture that is proposed. Here we can see the web interface that is connected to the EC2 instance running the Zipline application. This application sends the Spark jobs to this EMR cluster, and this cluster has access to some S3 buckets that holds the data and also stores the notebook in a JSON format. To measure the scalability of the new platform, 3 datasets of different sizes are created by replicating records. Time measurement were done for loading the data and performing queries. For measuring the time on the existing OHDSI system, I have measured only the time taken to query the data from the PostgreSQL database, and this does not include the time to create JSON files and visualize it. But since the new architecture does all of this in a single framework, the time measurement starts from data querying and ends at data visualization. Because of this, the time measurement for SQL architecture only includes data querying time. It appears to be faster than Spark. However, if we include the time for running R scripts and creating JSON, Spark outperforms it. This plot shows the time taken to load the data for both the architectures. The runtime for SQL architecture increases tremendously with dataset size, whereas Spark scales really well. This plot shows the percentage change in processing time for 2 queries on the 2 systems. We see the querying time for Spark only increases by at most 50% on increasing the dataset size. size, but for SQL architecture, this increase is in the range of 250 to 500%. We can clearly see that the new infrastructure is much more scalable. The Assure's dashboard on Apache Zeppelin is stored in a JSON format on a public S3 bucket. By using the Zeppelin Hub, a collaborative platform for sharing Zeppelin notebooks, anyone can access the new dashboard that is created for Assure's. So by using most recent big data tools like Apache Spark, Zeppelin, and Amazon Web Services, I have created an infrastructure for Azure that is scalable, faster, with better user interface and design. Thank you very much.